Hello all, my name is Debanjan Chaudhary and welcome to my YouTube channel. In this particular video, we are going to have an introductory understanding of what is set theory. Okay, so let us begin. So what do I mean by a set? Okay, so first let me write out four numbers 1, 2, 3 and 4. So you can see I have written four numbers 1, 2, 3 and 4. Now if I put curly brackets over here, right, we call it as a set. Why? Because it becomes a collection of a group of numbers, right? So what is a set? A set is nothing but a unordered collection of objects, okay, or group of objects. For example, this 1 2 3 4 is a group of object. Now if I write 2 1 3 and 4, okay, this is also a group of object, right? In this case, the object is nothing but numbered. So you can see here that this is properly ordered, right? It's ordered from ascending to descending order, right? I mean, it's ordered in ascending order. And this one, it's not ordered, although this is also a set. So just remember the definition. What is a set? A set is a unordered collection of objects. Okay, so let me give you some more examples, right? So I can write A, B, C and D. What is this? This is also a set. This is a set of four alphabets A, B, C and D, right? Now if I name this set as say S, okay, so I can also name a set, right? S equals A, B, C, D means that S is a set which consists of four alphabets, namely A, B, C and D, right? Okay, now let me just explain you one more thing regarding this set. So if I write S equals 1, 2, 3 and 4, okay. Now if I want to denote that this 1 belongs to set S, how do I write it? I write it in this way, 1, and this symbol is called as belongs to S, okay. So 1 belongs to S, right? It means that one element belongs to S, okay. So it is a correct statement. Now if I write 5 belongs to S, is it a correct statement? No, right? Because 5 does not belong to this set S. So rather I should write 5 not belongs to S in this way, okay. So this is a not belongs to symbol. Okay, now let me explain you how sets are basically represented, okay. So there are basically three ways in which sets are represented. Number one is called as the statement form, okay, statement form. Second one is called as the roster or tabular form, okay, and third one is called as the set builder form, okay. Now what do we mean by a statement form? Okay, so you know, a statement form is nothing but a set which is represented in a form of a sentence, okay. So if I write say statement form, right, statement form, if I write a set of numbers greater than 1 but less than 10, okay. So this is a set which is in statement format, okay. Now similarly, if I write the consecutive roster form, right, roster form of this particular sentence, how will I write? I'll write simply the numbers which is greater than 1 and less than 10, okay, the way which we have explained what is set, right? So how we are going to write 2, 3, 4, 5, 6, 7, 8 and 9. Yes, because it's said greater than 1 and less than 10, right? So it will start from 2 and end at 9. Now coming to our set builder form, which is the most important form, right? This statement form is not basically used, but this roster and set builder form are most commonly used, okay? So let's understand how do we write in the set builder form. So what we have said, we said that the number should be, the set of numbers should be greater than 1 but less than 10, right? So how do we write it in the set builder form? Okay. So we write it in this way: x such that x is greater than 1, okay, and x is less than 10, okay. So this is the way, this is the mathematical way of representing this. So someone if sees this, right, say x greater than 1 and x less than 10, he will be able to understand that x belongs from 2 to 9. This is an example of set builder form. Now let me just give you one more example, okay. Say the statement form is given in this way: set of all even numbers which is less than 10, okay, set of all even numbers which is less than 10. So this is the statement form. How do I write it in the roster form? So we know what are the even numbers. It is 2, 4, 6, 8, right? And we should not include 10 because it's less than 10. Now, how do I write it in the set builder form? Okay, we write it in this way: x such that x modulus 2 equals to 0. Okay. Now, what do you mean by this modulo operation? The modulo operation will basically give you remainder, right? For example, I take a number, say 4 I take, okay? So 4, if I divide it by 2, right? So 2 times is 4, right? And remainder is 0. Now, if I write 4 divided by 2, it is nothing but the quotient, right? It gives the quotient. But if I want to get the remainder, right? So we write 4 modulus 2. That is nothing but equals to 0. This gives the remainder. So this modular symbol basically denotes the remainder. So whenever the remainder of a number is 0, when it's divided by 2, right, it is an even number. It is said to be an even number. The definition of even number is it should be divisible by 2. So any number which is less than 10, okay, and divisible by 2, so it's a even number. So it is x such that x modulo 2 is 0 and we have to write x is less than 10. Now we have completed our set builder form of this particular even number. Similarly, if I ask you to give the set of all odd numbers which is less than 10, I hope you will be able to give it now, right? How are you going to do it? Obviously in the roster form, what it will be: 1, 3, 5, 7 and 9, right? How are we going to write it in the set builder form? So it will be x such that x modulus 2 not equals to 0, right? Because in case of an odd number, when we divide it by 2, it's not 0, right? And x is less than 10. That's it, right? In this way, we are going to get the set of all odd numbers which is less than 10. Now, okay, so we can name this set as S, right? Similarly, this is also S, right? Now, if I write say 9 belongs to S. Is the condition true? Yes, it is true because 9 belongs to S. If I write 8 belongs to S, is it true? No, it is not. Why? Because 8 does not belongs to S, right? So I hope you are able to understand, the various forms of set. Now we are going to understand what do you mean by cardinality of a set. Now we are going to understand what do you mean by cardinality of a set. Okay. So if we have a set S and I have written 1, 2, 3, 4. Okay. So there are 4 numbers. So the cardinality of a set S is denoted by mod of S and is nothing but equals to the number of elements inside this set. So for example, here we have got 4 elements, right? So the cardinality is 4. Now, if I give you some other example in the set builder form, right? So for example, I have written it in this way. Say S equals x such that x modulus 2 equals 0. Okay, then what will be the cardinality of this set S? Okay, so the cardinality of this set S is nothing but equals to infinity. How it is infinity? Because we haven't given any bounding conditions here, right? It is going to go on and check for every number, right? Say 2, 4, 6, 8, 10, 12, 14. In this way, it's going till infinity. Therefore, how many numbers we have? We have infinite numbers, right? Because we haven't given any bounding conditions. But if I write it in this way, that x modulus 2 equals 0 and x is less than say 10, then what will be the cardinality? Obviously we know S will be 2, 4, 6 and 8, right? Therefore the cardinality of S is nothing but equals to 4 because we have included the bounding box, the bounding condition here, right? Okay, so we are able to understand what we mean by cardinality. Cardinality of a set can be infinity provided the conditions are not sufficient, right? Now let us try to understand our last topic, that is nothing but equal set. Okay, so as I mentioned you, right, in the beginning of this lecture, that a set is an unordered collection of objects, right? Unordered collection. So if I write a set, say S1, if I write it in this way, 1, 2, 3 and 4, and say another S2, okay, and I write it in this way, 3, 2, 4, 1, right? Try to understand that these two sets, right, these two sets are nothing but equal sets. Why? Because the order may be different, but the objects, right, the numbers are nothing but same. Okay, here we have 1, here also we have 1, here we have 2, 2, 3, we have 3 over here, 4, we have 4, right? Therefore these two sets are equal sets. So what is an equal set? If all the elements of the sets, right, are nothing but the same, maybe the order may be same or different, the sets are said to be equal sets, right? Now one last point we need to understand or keep in mind, that in case of a set, right, in case of a set, we should always have unique object, right? So no repetition should be allowed. Okay, so if I write S as 1, 1, 2, 3, okay, so this is nothing but wrong. Okay, we have to write S 1, 2, 3. So it should be always unique, right? Now let us try to solve a problem on set builder. Okay, or maybe okay, So if I tell you, um, no, write all the numbers, or give a set which consists of all, positive numbers, or maybe all negative numbers, right? So how do we write it in a set builder form? Say I write s x such that x is less than minus, or maybe x is less than 0, right? Okay, so x should be less than 0. Now can you tell me how many numbers will be there, okay, inside this set? -1, -2, -3, okay, it will go till minus infinity, right? Because we haven't included any bounding condition. All right. So I think we are able to understand, what is set and how to represent set, and also, what are the various forms of representing set. We have talked about statement form, which is not obviously mostly used. We have also talked about the set builder form. We have talked about the roster forms, which are basically used mostly. Then we have talked about the cardinality of a set. No, we have talked about equal sets. We have also understood that we need to include only the unique elements in a set. We should not repeat elements. We have understood the definition of set. Okay, so I hope you are able to understand this set theory in an introductory way. Now, what I'm going to do is, obviously I'm going to write all this stuffs down, the link of which you will be getting in the description section below. Please do like and share my video if you have, like the content. Please do subscribe it, and uh, hope to meet you in the next lecture. Till then, stay safe, goodbye, and have a great day. Bye.